Welcome to the e-learning course concerning the familiarization of students with the maritime transport industry. In the present video we will take you to an educational tour concerning the maritime transport industry. During this e-learning course, significant information for the concept of blue growth, the economic overview, the required academic qualifications, the necessary technical skills and behavioral competences, and the potential job opportunities for a successful professional career in the maritime transport industry will be presented. Special focus will be given to the Eastern Mediterranean and Black Sea region. 71% of the Earth's surface is water. It is a very high percentage, and it is imperative the need to further harness the oceans, seas and coasts in order to create jobs and value, always from a sustainable point of view. This is the blue growth concept we have been hearing about. The blue economy represents roughly 5.4 million jobs and generates a gross added value of almost 500 billion euros a year, while the output of the global ocean economy is estimated at 1.3 trillion euros today, and this could be more than double by 2030. The European Commission has since reiterated that Europe should not miss this opportunity. Our coasts and seas have the potential to deliver growth and jobs in the years to come. Ensuring sustainable blue growth in marine and maritime sectors, we need highly qualified and skilled professionals. For these reasons, 4 marine and maritime economic activities have been selected as of strategic importance in the Eastern Mediterranean and Black Sea region. These include both traditional as well as emerging industries in the region, namely maritime transport, cruise tourism, marine aquaculture, and offshore oil and gas. Maritime transportation includes operating vessels, shipbuilding and ship repair. Cruise tourism industry consists of cruise lines, travel agents, key suppliers and cruise line partners including ports. Marine aquaculture refers to the culturing of species that live in the ocean. We consider marine aquaculture that takes place in the ocean, that is in cages, on the seafloor, or suspended in the water column. Finally, offshore oil and gas industry refers to the development of oil fields and natural gas deposits under the ocean. The majority of oil and gas production in Europe takes place offshore. As a result, the European-funded Project Mentor is focused on these 4 main sectors. Maritime transport is essential to the world's economy, as over 90% of the world's trade is carried by sea, and it is, by far, the most cost-effective way to move on mass goods and raw materials around the world. Without maritime transport and related developments in transport technologies, in particular containerization, globalization as we know it would not have materialized. From the consumer perspective, maritime transport is the main channel that promoted access to wide-ranging products at competitive prices. The world shipping industry is divided into sub-markets: liquid cargo, dry cargo, and container vessels that take finished goods. The cost of transporting a bicycle from Asia to Europe in a container is about $10, a kilogram of coffee just 15 cents, and a can of beer 1 cent. Global seaborne trade is doing well, supported by the 2017 upswing in the world economy, expanding at 4%, the fastest growth in 5 years. Global maritime trade gathered momentum and raised sentiment in the shipping industry. Total volumes reached 10.7 billion tons, reflecting an additional 411 million tons, nearly half of which were made of dry bulk commodities. Global containerized trade increased by 6.4%, following the historical lows of the 2 previous years. Dry bulk cargo increased by 4%, up from 1.7% in 2016, while growth in crude oil shipments decelerated to 2.4%. Reduced shipments from exporters of the Organization of Petroleum Exporting Countries were offset by increased trade flows originating from the Atlantic Basin and moving eastward towards Asia. This new trend has reshaped crude oil trade patterns, which became less concentrated on usual suppliers from Western Asia, supported by the growing global refining capacity, especially in Asia, and the appeal of gas as a cleaner energy source. Refined petroleum products and gas increased by a combined 3.9% in 2017. The top 5 ship-owning countries together account for 49.6% of the world fleet in deadweight tonnage. Greece has expanded its lead, adding 21 million deadweight in 2017. It now has a market share of 17.3%, followed by Japan at 11.7%, China at 9.6% and Germany at 5.6%. Ship owners from Greece specialize in oil tankers, in which Greece has a market share of 24%, as well as dry bulk carriers. Japan and China have their largest market shares in dry bulk carriers, with 20 and 16%, respectively. Ship owners from Germany specialize mostly in container ships, in which Germany has a market share of 20%. Among charter owners, that is, owners that do not themselves provide liner services but instead charter ships to liner companies, Germany has a market share of 1/3, down from 2/3 in 2013, and owners from Canada, China and Greece have expanded their markets. The container freight market improved considerably, following a difficult market environment in 2016. Global container demand grew at 6.4% in 2017, taking total volumes to an estimated 148 million TEUs. The strong development in global container shipping demand in 2017 reflects a fundamental improvement in the global economic environment. The dry bulk market underwent a remarkable recovery in 2017. Growth in demand for seaborne dry bulk surpassed the fleet growth, as demand for commodities went up, while the surplus of vessels gradually continued to diminish. Seaborne dry cargo shipments increased by 4.4% in 2017, up from 2.0% in 2016. Overall, 2017 proved to be a challenging year for the tanker market, mainly because of the pressure faced by markets from continuous growth in supply capacity, particularly in the crude tanker sector that was matched by a relative deceleration in demand growth. It is estimated that global tanker trade expanded at an annual average growth rate of 3.0% in 2017. The crude oil tanker fleet grew by 5% and the product tanker fleet grew by 4.2%. Rapid growth in the capacity of tankers carrying crude oil and products has further affected market balance, particularly in the crude oil sector. Maritime transport is a highly regulated industry. Some of the most important regulatory organizations are introduced next. The International Maritime Organization (IMO) is the United Nations Systems Regulatory Agency for the maritime sector. Its global mandate is safe, secure and efficient shipping on clean oceans. IMO pursues that mandate by adopting international maritime rules and standards that are then implemented and enforced by governments in the exercise of flag, port and coastal state jurisdiction. The European Maritime Safety Agency is one of the EU's decentralized agencies, based in Lisbon. The agency provides technical assistance and support to the European Commission and member states in the development and implementation of EU legislation on maritime safety, pollution by ships and maritime security. The International Labour Organization (ILO) brings together governments, employers and workers of 187 member states to set labor standards, develop policies and devise programs promoting decent work for all women and men, to protect the world's seafarers and their contribution to international trade. The ILO has adopted over the years some 70 instruments, 41 conventions and related recommendations through special maritime sessions of the International Labour Conference. The ILO is international standards for this sector establish the minimum conditions for decent work and address almost all aspects of work, including minimum requirements for work on a ship such as minimum age, medical fitness and training, provisions on the conditions of employment such as hours of work and rest, wages, leave, repatriation, accommodation, recreational facilities, food and catering, occupational safety and health protection, medical care, welfare and social security protection. In addition, they address issues such as pensions and an internationally recognized document for seafarers, a seafarer's identity document to assist in border control matters. IACS is a not-for-profit membership organization of classification societies that establish minimum technical standards and requirements that address maritime safety and environmental protection and ensures their consistent application. It carries out this responsibility through its panels, expert groups and project teams and provides a quality system certification scheme that its members comply with. As an assurance of professional integrity and maintenance of high professional standards, IACS is recognized as the principal technical advisor of IMO. The U.S. Coast Guard responsibilities include search and rescue, maritime law enforcement, aids to navigation, ice breaking, environmental protection, port security and military readiness. At the start of 2014, the EU-controlled fleet comprised of 660 million deadweight tons, 450 million gross tons, and 23,000 vessels. The EU-controlled fleet is dominated by three types of vessel: bulkers 28% of gross tonnage, oil tankers 25% and container ships 25%. The EU-controlled fleet represents 40% of the world's gross tonnage. In some types of vessel, however, the EU-controlled share is much higher. Most notably, the EU controls 60% of the world's container ships and 43% of the world's oil tankers. Within the EU-controlled fleet, the strongest growth between 2005 and 2014 was recorded amongst offshore vessels. The EU's share of the world offshore fleet increased from 28% in 2005 to 37% in 2014 in gross tonnage terms, although smaller in terms of their significance within the EU fleet. EU countries control 61% of roll and roll-off vessels, 57% of ferries and 52% of multi-purpose ships. This sector is particularly important in terms of economic impact because it is more labor-intensive than many other subsectors, and many of the jobs created are high-skill, high-value positions. In 2012, the EU shipping industry is estimated to have directly employed 590,000 people. It is estimated that around 4/5 of posts, or 470,000 jobs, are based at sea. It is tentatively estimated that around 40% of these seafarers are EU or European Economic Area nationals. The skills and experience of seafarers are vital to the smooth functioning of the shipping industry, and are also highly valued by firms in the wider maritime cluster and beyond. Indicative estimates suggest there were approximately 38,000 students cadets in maritime academy-type training in 2012. An 11% increase from 2004. In 2012, the EU shipping industry is estimated to have contributed €56 billion to GDP, and generated tax revenues of €6 billion. Shipping is a high-productivity industry. Each worker is estimated to have generated €88,000 of GDP, significantly above the EU average of €53,000. The shipping industry indirectly supported an estimated €59 billion contribution to GDP and 1.1 million jobs through its European supply chain in 2012. The spending of wages by those employed in the shipping industry and its supply chain supported an estimated additional €30 billion of GDP and jobs for 550,000 people. Taking these effects together, the total GDP contribution of the European shipping industry in 2012 is estimated to have been €145 billion. The industry also supported employment for an estimated 2.3 million people, and tax revenues estimated at €41 billion. For every €1 million the European shipping industry contributes to GDP itself, it creates another €1.6 million elsewhere in the European economy. In the context of the Mentor project, a total of 119 questionnaires have been collected and have been statistically elaborated. They represent 4 countries: Bulgaria, Cyprus, Greece and Romania, and the aim of this analysis was to determine the required academic qualifications, technical skills, behavioral competencies as well as the professions with the highest demand in the maritime transport industry. The questions were divided into 2 sets. The first set of questions was referred to the current trends and needs within the industry, whereas the second one to their future analogs. Since the target group of this e-learning course is the students, the presented results are referred to the future identified gaps and trends within the maritime transport industry. Academic qualifications are the degrees and diplomas that an individual has acquired, whether by full-time study, part-time study or private study, whether conferred in the home country or abroad, and whether conferred by public or private educational authorities. As far as the necessary academic qualifications are concerned, all gathered data regarding tertiary education were collected and grouped based on its relevance. As a result, 9 main categories of tertiary education degrees identified in the questionnaires, namely, naval architecture and marine engineering, mechanical engineering, computer science, economic studies, maritime studies, environmental engineering, other specialization courses or lower-ranking crew, accounting and shipping law. These academic qualifications can be classified based on the proposed taxonomy by the International Standard Classification of Education. The International Standard Classification of Education 2011 has 9 levels of education, from Level 0 to Level 8. Levels 0 to 2 represent lower educational certificates. Levels 3 to 4 refer to medium educational certificates, and finally the levels 5 to 8 correspond to higher-level educational degrees and diplomas. The elaborated statistical analysis was performed on 2 different levels. The first level was based on the results of the whole region for the maritime transport industry. At the second level of the analysis, all the available information can be distinguished between the 4 countries of interest: Bulgaria, Cyprus, Greece and Romania. An initial examination of the aggregated results of the region provides significant insight concerning the academic degrees with the highest demand. A degree in naval architecture and marine engineering is located in the first place for the next decade with 29%. In the second place can be found the degrees in economics, business, shipping and finance, marketing, finance, ship trading and broking, shipping with 19%, a degree in computers, electrical engineering, electronics, data science is located in the third place with 12%, degrees in maritime studies, nautical sciences, merchant marine officers, navigational studies follow in demand with 11%. Finally, degrees in mechanical engineering, chemical engineering, environmental engineering, logistics, general academic qualifications, other specialization courses. Lower-ranking crew will also be in high demand in the maritime transport industry the next decade. The presented results account for the 95% of the collected answers. Another significant aspect of the Mentor project concerns the pairing of the academic qualifications with the highest demand in the next decade in the maritime transport industry. With the existing academic institutions in the Eastern Mediterranean and Black Sea region, that provide the necessary educational courses for these qualifications. In this context, some illustrative examples are presented. By studying at technical universities with schools or departments of naval architecture and marine engineering, a potential student can obtain the respective degree: the Technical University of Varna in Bulgaria, the National Technical University of Athens, and the University of Galati in Romania are some proposed institutions for this academic qualification. Similarly, the National and Kapodistrian University of Athens and the Technical University of Crete in Greece and the European University Cyprus provide courses in the field of computer science. The duration of the studies varies between 3 and 5 years. Typically, merchant marine officers are Maritime Academy graduates. Institutions that provide relevant education and training are the Naval Academy Nikolai Vaptsarov in Bulgaria, the Constanta Maritime University, and the Merchant Marine Academy of Asperpyrgos near Athens. In addition, based on the elaborated statistical analysis, a degree in economics is characterized as the second highest in demand qualification. A student who focuses on this field has a variety of institutions to choose from, for example the University of Piraeus and the Athens University of Economics and Business in Greece and the University of Nicosia in Cyprus. Technical skills are the abilities and knowledge needed to perform specific tasks. They are practical, and often relate to mechanical, IT, mathematical, or scientific tasks. Some examples include knowledge of programming languages, mechanical equipment, or tools. While technical skills are often most important for jobs related to information technology and other fields in the sciences, many other industries also want employees with at least some technical skills. Many of them require training and experience to master. 29 technical skills were identified as necessary in the upcoming decade for the maritime transport industry. Indicatively, some of them refer to seamanship, occupational health and safety, big data analytics, management systems, electronics, energy management, technical design, hardware, computer IT, languages. The statistical elaboration of the Eastern Mediterranean and Black Sea region show that the most crucial technical skills for the next decade will be machinery damage and repair and technical writing and reporting with 9%. Management systems follow with 7%. In the third spot can be found hardware computer IT with 6%, energy management, testing, inspection and verification, customer care, communications follow with 5%, whereas seamanship, languages, technical design, project management, operating systems, electronics, diagnostic engineering, big data analytics, account for 4% each. The remaining technical skills are occupational health and safety, risk assessment, welding materials and non-destructive examination, electrical and control, social media, safety, survival, firefighting, other, first aid, medical care, driving specialized vehicles, auditing management systems, training others, navigating specialized crafts. Competence is defined as a cluster of related abilities, commitments, knowledge, and skills that enable a person or an organization to act effectively in a job or situation. Because each level of responsibility has its own requirements, competence can occur in any period of a person's life or at any stage of his or her career. In the distributed questionnaire, a pre-selected list of behavioral competencies was included, and participants should indicate the top 3 required for the maritime transport industry. The aforementioned competencies are leading, persuasive, deciding, planning and organizing, business awareness, analyzing, problem solving, communication in writing, networking, teamwork, collaboration, flexibility, adaptability, resilience, personal motivation and adherence to principles and values. The statistical elaboration of the Eastern Mediterranean and Black Sea region show that the most important behavioral competences for the next decade will be planning and organizing and teamwork collaboration with 14%. Flexibility adaptability follows with 9%. In the third spot can be found deciding, analyzing problem solving, communicating in writing, resilience with 8%. The list is concluded with leading, customer orientation, personal motivation, communicating orally, networking, adherence to principles and values, business awareness, persuasiveness, interpersonal sensitivity, which vary between 7% and 1%. The maritime transport industry offers a wide range of occupations for both entry-level and experienced professionals. Maritime transport professions have been classified into different categories in order to present them in a comprehensive manner. In the context of the Mentor project, a wider profession categorization was implemented in order to analyze in depth the maritime transport professions with the highest demand in the next 10 years. Hence, 16 maritime transport profession categories were materialized, namely engineers, engine room officers, bridge officers, onshore officers, manager, lower-ranking deck crew, operations personnel, technicians, lower-ranking engine room crew, office personnel, port operations personnel, marketing PR personnel, logistics personnel, accounting personnel, lawyers, inspectors. Some of the aforementioned categories represent more than one profession or post. For example, the naval architecture and marine engineers, the mechanical engineers and the electrical engineers are included in the category of engineers. Likewise, the technical manager, operations manager and HSQE manager belong to the category of managers. The master, second mate and third mate belong to the category of bridge officers, and the chief engineer, second engineer and third engineer belong to the category of engine room officers. The statistical elaboration of the collected data provided significant insight with respect to the professions with the highest demand in maritime transport. The professions in engineering come with the highest demand with a percentage of 32%. The demand for engine room officers follows with 10%. Third in demand are the professions of bridge officers, onshore officers and managers with 8%. The remaining professions refer to lower-ranking deck crew, operations personnel, technicians, lower-ranking engine room crew, office personnel, port operations personnel, marketing PR personnel, logistics personnel, accounting personnel, lawyers, inspectors, with percentages that vary between 6% and 1%. A naval architect is a professional engineer who is responsible for the design, construction and repair of ships, boats, other marine vessels and offshore structures, both civil and military.
My name is Zurnitsa Petrova. I'm naval architect and marine engineer, and I have a ship design for 2 years. Many years ago, my curiosity to vessel architecture and sea as well were my motivation to study shipbuilding and technology and Technical University of Varna. To be a naval architect is not easy, and sometimes it's not suitable for everyone, but I like that our job is full of opportunities. Nowadays, from one marine engineer is expected to be flexible. Every project is unique. The tasks are different for everyone. Our responsibilities depend from the scope of work because we are involved in different stages of ship design. We begin with initial design, move on technical documentation, and finally prepare the work documentation. Every stage is challenging, and we have to be well versed in the subject like ship theory, design, technology. This is very important for us as professionals if we want to be competitive at our work. Our job is quite responsible. In a BIM project, we don't work alone, and our decisions reflect to other colleagues abroad. We have to prepare very carefully the technical documentation because every mistake brings losses in our schedule and after that in production. When our work in the design stage is implemented in reality, I'm really proud of this. This feeling is incredible. Our education is quite specific. We study mainly technical disciplines related to vessel as a construction. Unfortunately, there are not so many young people who would like to study for naval architects. However, those of them who have the courage to finalize their education will have the possibility to begin their professional development. Our branch has a significant potential for development, and our company knows how to make investment in their people. Often, colleagues ask me, what is the advantage to work in IHB ship design? The answer is simple. There are not so many branches where you can work in multinational area. Most of our customers are leading worldwide shipyard and ship owners. We have the chance to meet a wide range of culture and business styles, which leads to accumulation of knowledge in a multicultural environment. This is an invaluable chance and important advantage for every professional in our field. To our future colleagues, I would like to say, of course, you have to have a maritime education, but the most important part is to be motivated and encouraged to work in shipbuilding industry.
Shipyard workers built and maintained ships designed for military and civilian use. The workers performed an array of jobs within the industry. They included painting, electrical work, welding, plumbing, insulating, repairing and general contracting.
I'm Evelyn, I'm here from Varna. I work here at Kereze Odessa's Varna ship repair yard, so I'm working here from 2014 and I'm foreman from 2 years ago. I work at steel department and we're here repairing the ship's hull. I'm here because probably of my father. He's working here as a carpenter, and from little boy I was walking around the shipyard and was amazed by the ships and all the new stuff that I saw. And after that, when I grew up, I started following the path of ship repairment. So this is one good opportunity to work here in Varna. Probably the biggest opportunity the city presents for bright young people like me. What I really like here at the job is that you're doing something from nothing. You're cutting, welding and taking apart something that is damaged, and you're rebuilding it like it's a brand new thing. So yeah, I like this really much. All the big machines, the ships that are here, you're feeling small and you're like an ant. So you're walking around this big ship and you're making it pretty again. So one of the most important things is to have a good team. The ship repairing is based on the people. It's not the machine, it's not all the equipment, it's the people that are working in here. So if you have a good bunch of people working really hard, you can lift mountain like this. For everybody that are not sure where to start their career, I definitely encourage you to choose a career like mine.
A master is the professional qualification required for someone to serve as the captain of a commercial vessel of any size, of any type, operating anywhere in the world. Masters, also known as captains, are in overall command of the ship and are responsible for the safety, efficiency and commercial feasibility of the ship. A master's license states the area of operations and maximum gross tonnage of vessel for which that license is valid. The master is in charge of safety of the crew, vessel and cargo, He is charged with ensuring that all international and local laws are followed properly, and that all management policies are fully complied with. The master also ensures compliance with the vessel's security plan, as required by the IMO ISPS code. The plan, customized to meet the needs of each individual ship, spells out duties including conducting searches and inspections, maintaining restricted spaces, and responding to threats. This position comes with an average annual salary of about 85,000 euros.
Okay guys, I'm going to increase to full ahead initially. My name is Robert Sareva and I'm a captain with Chevron Shipping. It started all with my father. My father is a captain. He took me on a ship with him when I was 5 years old. One of the best pieces of advice that he has ever given me was to focus on people, not just to focus on the equipment, because everything else is fairly predictable or repairable, but it's the human element that you need to focus on. The successful operations on the ship are based on good and effective communication. In my view, the model of what a good captain is has changed a little bit from what we are used to. Before, the captain was a very authoritarian person. Today, the captain is a person that should filter all the incoming communication rather than shutting off whatever ideas the officers or the crew may have. I try to get myself out for my rounds on deck. I choose different areas every single time. There is a clearance on one side and this is my chance to interact with the crew members. I strongly believe in that habit because that sends the message that the captain's interested in the running life of the ship. Looks like Olex has been doing a good job with this. Among all of that activities, the number one priority for myself is the safe passage of this ship. Life at sea is definitely very much different to what everybody else does ashore. We tend to split our existence in between here and the family life. I feel when I'm coming here, I find my solitude. I have a daughter, and it was one of the most exciting moments throughout my career to have my daughter together with my father on board. That kind of made her realize what the job is actually looking like. So it was a big discovery for both myself and for my daughter. Really good moment. It's been 11 years now that I've been working for Chevron. I've got the feeling that I'm the part of a greater organization. Therefore, you are more and more motivated to contribute to the greater success of this company.
The chief engineer of the ship is the head of the technical department of the ship. It is his duty to ensure that the engine room machinery works properly for a smooth voyage. According to the Safety of Life at Sea Convention, it is the responsibility of the chief engineer to look after the safety of maritime professionals working in the engine room. This position comes with an average annual salary of about 68,000 euros.
The main purpose is to keep a good, efficient and safe operating plant. It's got to be done correctly, and we make sure that it is a good job. When we fix something, it is a good fix. My name's Michael Wilson. I'm the chief engineer on the Maersk Separuk. Disconnect 1 or 2 and measure it. So if you just take off scan. Teaching and training, passing on our knowledge is very important. I will put it online. We have a lot of junior officers coming through, from cadets through to 4th engineers and 3rd engineers. We have to look to the future as well, so training is very critical. Including myself, I'm always learning. Constant care is very important. It's important that we also, every one of us in the engine room and on deck, we do the job well today, and it has to be good for tomorrow as well. That's critical for us, and it makes an efficient operation as well. You put your best efforts into new people. Hopefully they take as much as they have off you, and they'll put their idea or slant onto it as well, and they will improve. I hope that and want that the next man will be better than myself, making the ship an even more efficient and safe.
The third engineer meets the mandatory minimum requirement to act as an engineer watch officer in the engine room. He/she oversees the operation, maintenance and repairs of subordinate engineers and engine rating members of the ship's engineering team. The third engineer is familiar and proficient in the maintenance and repairs of main and auxiliary engines and their associated systems and equipment. He/she is responsible for the maintenance of the ship's safety and emergency equipment. The third engineer is an organized person who is able to multitask at times and is cognizant of the regulatory requirements of engine rooms. The third engineer must pass a color vision test and must fulfill the requirements stipulated in the standards of training, certification and watchkeeping for seafarers issued by the International Maritime Organization. This position comes with an average annual salary of about €27,000.
I always liked working with technical stuff, and there's a lot of machinery on a vessel like this. What I like about working with the engine is finding problems and solving the challenges we have on board. My name is Jimmy and I'm a third engineer.
The role of a marine surveyor is extensive, encompassing tasks such as inspections and examinations of marine vessels. It is vitally important for both new and existing vessels to comply with necessary safety and certification standards. It is the responsibility of a marine surveyor to determine the certification of a vessel through conducting detailed surveys. The marine surveys are not exclusive to the vessel itself but also the equipment held on the vessel. Generally, a marine surveyor's examination will include the structure, machinery and equipment of the vessel to ascertain its condition. The services of a marine surveyor will be enlisted when obtaining marine insurance. This is to determine if the vessel complies with the insurance policy. Additionally, with respect to marine insurance claims, a marine surveyor will be used to qualify what damage has been caused. Typically, a marine surveyor is a highly qualified individual. The general responsibilities of a marine surveyor extend to conducting surveys on a vessel's condition and the equipment of the vessel for the lifetime of that vessel, performing inspections to ensure marine standards are adhered to, perform examinations and inspections in line with the IMO, investigate marine accidents and marine insurance claims, witness tests for safety machinery. This position comes with an average annual salary of about €65,000.
My name is Stein Arild Holsvik. I'm 28 years old and work in DNV GL Ålesund as a surveyor. I started in DNV in 2010. I got hired through Maritime Transport, and internally in DNV I participated in DNV National Trainee Program.
My name is Rolf Ole Remerholm. I'm 30 years old. I now work as an electrical surveyor at DNV GL Ulsteinvik. I started my trainee program here in Ulsteinvik, doing certification of new buildings and main components.
As a trainee, you can end up doing all kinds of work. One day, you may go to the manufacturer in order to do a certification survey of important components such as thrusters or engines. The next day, you may go to a new building shipyard in order to overlook the construction of the ship and the installation of vital parts such as the engine. On the third day, you may go to a fairly old ship in order to make sure that both the hull and all the vital important components are working in a safe and good way.
As a trainee, it's expected that you are willing and show interest to learn and participate in the daily work at the station.
Most of all, I'm looking for someone that are interesting and are willing to learn more.
Mainly I look for candidates who are engineers within the maritime field. Being an engineer is just a starting point when you start joining the NVGL.
And of course they need to have good results in their specialties and these things to show that they are able to learn. But I think most of all it is the interest and the willingness to learn and to develop themselves further. In Sunnmøre and at this district we have a lot of key players in the maritime industry. We have the ship owners and their crew. We have the producers of all the equipment the ship owners need on board the vessels. We have the ship designers and the yards. And all of these are playing a very important role together actually. In many ways we are making each other good.
If you hope to be a trainee, I would advise you to take relevant subjects and try to get relevant experience. Seek information about the DNVGL, what we stand for, what we do, what a surveyor typically does. And if you think the mix between hands-on experience and office work is something that fits you, make sure to apply.
The career mentoring process can be considered as a valuable tool which will assist in discovering the student's potential and aptitude and accordingly suggest the right career path. There are students who are either confused or uncertain about their employment preferences. Moreover, there are students who, despite having a clear idea of what they want to achieve in life, do not know the path they need to follow or the requisite academic qualification. In addition, some students might also have preconceived beliefs about certain professional fields. Hence, career mentoring will also help students overcome these by presenting the true facts. The ultimate objective of the Mentor Project was to develop a framework to provide career guidance and occupational orientation not only to students but also to existing graduates and professionals, and to increase their awareness and properly inform them on job opportunities and relevant prospects in the blue sectors by selecting the proper path. In the context of this e-learning course, the presented framework is adapted to the students. The aim of this framework is to present to the students the opportunities and the required technical skills and behavioral competencies for future employment in the maritime transport industry, and to provide them viable educational options paths. These educational paths are generated based on the identified boundary conditions and they are the outcome of the mentoring process which incorporates various guidance layers. The starting point of the career path reflects the current occupational status of the mentoree and in our case is the student who seeks a future employment in the maritime transport industry. The end point of the career path is the admission of the student to a vocational or academic institution related to an initially selected blue profession of the maritime transport industry. The guidance layers include the awareness familiarization with a selected number of blue professions through speeches, seminars, real-world success stories and semester projects. The identification of the necessary technical skills that the student should develop in order to achieve his or her admission to the selected vocational or academic institution. The identification of the required behavioral competences that have a direct link with the selected maritime transport occupation. The determination of the available vocational or academic institutions and the respective academic degrees based on the taxonomy by the International Standard Classification of Education. The geographical location of the vocational or academic institutions and the necessary time for the acquisition of the proposed degrees. This adapted framework for the mentoring of the students generates a series of possible educational threads. In order to select the most optimal one, a constraint regarding the total cost of each thread is introduced. The final selection of the path is based on the cost in monetary values that the family of a student should invest for his/her educational improvement. Finally, a selected code of ethics is implemented during the whole mentoring process and sets the foundational standards. Let's see an indicative implementation of the developed adapted mentoring framework. All available blue sectors: maritime transport, cruise tourism, marine aquaculture and offshore oil and gas are presented to a Greek student, and the student decides to follow a career path in the maritime transport industry. The blue professions that are most in demand nowadays and in 10 years are presented to him/her in order the student to identify the most suitable one based on his/her interests. In this case scenario, the student expresses his/her interest in the blue profession of the ship captain. As a result, the values for the boundary conditions are student and admission to an education institution. For obtaining a degree concerning the blue profession of the ship captain, the student should initially acquire the degree of the bridge officer, then gain experience in the maritime industry, and finally advance in the ranks within the industry and work as a ship captain. Having defined the boundary conditions, the modified framework generates a series of educational threads. Initially, the mentor should increase the awareness of the student regarding this blue profession. A combination of speeches and real-world success stories are organized by the Greek representative of the Blue Career Center and presented to the student in order to enhance his/her familiarization concerning the content and the requirements of this profession. The next step of the mentoring process refers to the identification of the necessary technical skills of the student. The student should have a good knowledge of maths and physics during high school. Subsequently, the identification of the required behavioral competencies follows. The student should develop teamwork and problem solving through the assignment of group projects in high school. The next step includes the mapping of the available educational institutions for this profession. The mentoree has expressed his desire to study in his country Greece and not abroad. This initial constraint leads to the recording of 9 available merchant marine academies in Greece. Only one merchant academy is located near the residential area of the student, whereas the remaining 8 academies are established in different towns. The time duration for obtaining the degree of bridge officer is the same 4 years for all the available academies in Greece. In this scenario, the student decides to follow the most cost-effective educational path. The cost constraint operates as a filter and ensures the optimal selection of an educational path from the mentoree by taking into consideration the economic affordability of his/her family. At this point, the e-learning module for the familiarization of students with the maritime transport industry has come to an end.